In this video, we're going to see how to use the formula for the nth term of a geometric sequence to find the nth term of a geometric sequence. So again, here's the formula. So a sub n represents the nth term, and that's equal to the first term a sub 1 times r to the n minus 1 power. Take a moment to write this formula down if you have not already. And we're going to see it in a couple of examples. In the first example, we're going to find the ninth term of a geometric sequence with first term 3 and common ratio -2. So I'm just keeping track of the important pieces of information. The first term here is 3, a sub 1, r is -2, and n here is 9. So substituting those into the formula, we have 3 times -2 to the 9 minus 1 power. Once again, order of operations here. Subtraction first to simplify that exponent, then we're doing the exponential expression, raising -2 to the 8th power, and then whatever that result is, multiply by 3, and your final result should be 768. Once again, you can enter this into your calculator all at once, but all of the parentheses that you see should also be typed into your calculator. You could maybe do the simple subtraction, so you don't have to worry about typing all that into the calculator, but you do definitely need the parentheses around that -2. Here's a second example. So here we're going to find the 12th term of the sequence -4, 12, -36, 108, -324, etc. So we should verify that this is in fact geometric by looking at if we are multiplying the same thing over and over again. So we do see that the terms are changing sign, negative, positive, negative, positive. So if we are multiplying by something, it is a negative. And then we could think about what would we multiply by to get to 12, which would be a 3. And that same number, if we multiply by 3, 12 times 3 is 36, times 3 is 108, and so forth. But because the terms are changing opposite sign, we know that r is -3. Our first term is -4, it's always just the first one in the list. And since we want the 12th term of the sequence, n is 12. So once again, plugging everything into the formula, a sub 12 equals -4 times -3 raised to the 12 minus 1 power. Once again, if you're typing this in all at once, make sure you have parentheses around that negative base, that -3. And you could maybe just enter the exponent in as 11 just to avoid having to type more things into your calculator. The order of operations, if you're doing it one step at a time, subtract the exponent first, then -3 to the 11th power, and then multiply that by -4. The result here should be 708,588. And for our last example, so here we're finding the 20th term of the sequence, 18, 6, 2, 2/3, and so forth. So we should verify that this is geometric by seeing if we are multiplying by the same number to go from one term to the next. And you see here that the terms are decreasing, so you might think about this as at first as dividing. If we go from 18 to 6, we could divide by 3, and then 6 divided by 3 is 2, and then 2 divided by 3 is 2/3. But remember, we always want to write r as something that we are multiplying by. So dividing by 3 is the same as multiplying by 1/3, which is the reciprocal. So r here is 1/3. Our first term, a sub 1, is 18, and we want the 20th term in the sequence. Now, let's use our problem-solving skills here. Let's think about reasonableness. Think about where these terms are going. We see that after the 4th term, we're already in a fraction, something less than 1. So if we continue to multiply by 1/3 and 1/3, that number is going to get smaller and smaller and smaller. So we will have a smaller fraction. It is a positive. They're all positive. They're all the same sign. So we don't expect the sign to change, which means r should be positive and our final result should be positive. So we're plugging everything into our formula. A sub 20 equals 18 times 1/3, the entire fraction raised to the 20 minus 1 power. So 20 minus 1 is 19. So we're raising 1/3 to the 19th power. Now, if you're doing this in your calculator, if you type in 1/3, even in fraction form, and raise it to a power, your calculator is going to give you a decimal. And just depending on how small that decimal is, your calculator may not be able to turn it back into a fraction, even if you're using those graphing calculators, because it has so many digits and it will round off. Your calculator might also give you something in scientific notation. So to avoid that, we're going to think about each part of the fraction and raising it to the 19th power. 1 to any power is just 1. So if I raise 1 to the 19th power, I have 1 on top, and 3 to the 19th power gives me this number that you see down below here. So this is 1,162,261,467. That's what you get when you raise 3 to the 19th power. Now I'm just multiplying that by 18. Again, even if you did this in your calculator, you might get a decimal that looks approximately like the decimal that you see here. But if we wanted to put this in exact fraction form, we could write it as 18 over 1,162,261,467. But if we wanted a sense of how small that fraction is, decimal form does help us do that. My calculator put it in scientific notation, so I had a decimal point between the 1 and 5, and it was times 10 to the, I believe, -8th power. So that's why you'll see 7 zeros here. So one thing that we will be doing in this class is being able to understand the technology, which is, in our case, a calculator. Even your smartphone calculator will put these small numbers or even very large numbers in scientific notation. So if you have any questions on what's coming up in your calculator and how to interpret it or how to use it to do something like 1/3 to a power, then please ask. Well, that concludes our video. I hope you enjoyed it.